Okay, sir. Very good morning, everyone. Myself, Shubham Kumar, Assistant Professor in Computer Science Engineering Department, Dr. KNMIET Institute of Engineering and Technology, Modi Nagar. I welcome Honorable Chairman, sir, our mentor, Professor Dr. R.K. Khandal, sir, Director, sir, HODs, and other faculty members, as well as our alumni. Mr. Dipanshu Gupta, working as a model lead in multinational company Mindtree Limited, Maharashtra, 2015 batch pass out, and our panelist, Dr. Professor Prabhat Kumar Srivastava from KNGD Modi Engineering College, Mangalore. It is honor to be here with you today. The topic of webinar is advanced clipping algorithm in computer graphics. Now we would like to tell you about clipping. The term clipping in the context of computer graphics is a method of selectively enable or disable image synthesis within a defined region of interest. There are three students, Piyush, Himanshu, and Nikhil, third year, CSC third year. They will explain us various important concept and idea about clipping algorithm that ever been discovered in area of CG. So the algorithm names are point and text clipping, Open shooter line clipping algorithm, Cyrus Beck line clipping, and Shooterland Hodgman polygon clipping. Now I would like to invite Piyush. Piyush, you can start.
Thank you, sir. Good morning, director, sir, all the faculties, and our respected alumni. I'm Piyush Pandey, present on this webinar to explain the topic of clipping. So, before we start clipping, it is necessary to understand the whole topic. So these are mainly the basic of the topic. So first one is coordinate. So coordinates are distance or angles which are in numbers, which help to identify any particular point in 2D or 3D space. So basically, coordinates are help in determining the position of any point. So after coordinate, we have to know about window and viewport. So these two terms are very similar, but help to understand the remaining clipping portion. So in computer graphics, mainly a graphical control element consists of a virtual area containing some graphical user interface. So mainly the window help us to decide that which points should lie inside and which points should not. And after that we have viewport. So viewport is an area viewport is an also rectangular type area which is used to show only a particular portion which lies inside the window and just eliminate which are not inside the window. So we can understand this topic by figures. So as you can see, we have two figures, window and viewport. At left side of the screen, we have a window, and at right side we have viewport. So as you can see, we have an x-axis and y-axis. So here we have a rectangular screen. This rectangular screen is known as window, and we have a figure. As you can see, it is a something triangle-like figure. So it is a window. So here we have a rectangular screen, and after that we have a whole figure. But when we came to viewport, so here only we have the things which is just remain after clipping. Clipping, which we know later. Clipping basically means to clip out the things. So in viewport, we have only the remaining portion of the figure of the area. So after that, we came to definition of clipping. So before we know what is clipping, there is also a small definition of clipped part. So the portion left outside the region of the window in computer graphics is called clipped part. Means if you have any line or something like you have any figure. So when it comes to come to screen, and if the portion lies inside the screen, then it is called. Then it is says that the line will lie inside the figure. and the remaining part which just clipped out is known as clipped part. And the whole process of displaying inside image of in the window is known as clipping. So the portion which is eliminated is the portion which is eliminated is known as clipped part, and this procedure is known as clipping. After that, we came to what is the need of clipping. So need of clipping in computer graphics is basically to remove any line segment or object from a particular window, or say a particular plane. Clipping is used to eliminate the things which are not necessary. After that, we came to the types of clipping. So we have basically four types of clipping: point clipping, line clipping, polygon clipping, and text clipping. So we read one. So we just understand these four one by one. So first one, we have point clipping. So point clipping just tells us whether a point lies inside the window or not. Like we have say any point. So it is very important that how can we decide that that point will remain inside the window or lies outside the window. So for that, it have to satisfy some conditions, which is listed here. As you can see, v, x, y, which are coordinates, will be displayed on screen if x is greater than or equal to x minimum and less than or equal to x max. And same thing used for y axis, like y is greater than or equal to y minimum and less than or equal to y. So if any point just satisfy these two conditions of x axis and y axis, then that point will be lie inside the window. So here we have a figure of point clipping. As you can see here, we have x-axis and here we have y-axis. So we have a rectangular plane, as you can see. So there are some points which are named P1, P2, P3, P4. So those points which are rounded by red color, surrounded by red color, these points are clipped out because these points did not satisfy the condition which we read on the last page. And those points which lie inside the rectangular P5 and P9, these points just satisfy that condition. So it is just a small formula by which we can decide that what conditions should be required for any point to exist inside the window or not. Now I would like to call Himanshu to further explain the remaining types of the clipping.
Thank you, Piyush. Good morning, faculties and respected alumni. So I'm going to present line clipping. So let's start. What is line clipping? So the basic concept of line clipping is also the same as point clipping. In line clipping, we just cut off the portion which lies outside the window and only keep the portion that is inside. And it is just as same as point clipping, which Piyush has already explained. So one of the algorithm which I'm going to discuss is Cohen-Sutherland line clipping algorithm. So before going to it, let's discuss first what was the need of it. So we did had priorly a brute force line clipping algorithm, which was very expensive in terms of computation. Means it used to calculate point of intersection for each and every line. So this gave an advantage to our algorithm. That is, it reduced the number of lines, the number of points of intersection we have to calculate it for the line were reduced in significant amount. So now let's discuss why Cohen-Sutherland. So the algorithm was actually developed in 1967 during flight simulator work by Danny Cohen with the help of Evan Sutherland. Hence the name was given Cohen-Sutherland. So moving forward with its concept. So this algorithm also uses the same clipping window concept. In this, window is used as the reference to select whether a line is to be accepted, rejected, or other possibilities, which I would be discussing in my next slide. So here are the possibilities. Now let's talk about the very first possibility. First is line is accepted. If we can see in this table that if a line is completely inside window, then we don't have to do anything. We don't need any clipping or any other thing, and line would be completely accepted. For a second case, that line must be clipped. That if we know that one point of the line is inside and one is outside the window, then we know that we need to apply clipping because some part of the line would be lying inside the window. that means that the line must be clipped. But the third one is a bit of complex. That is, we don't know what we have to do. That is, both the endpoints lie outside, and we don't know whether a line would be completely rejected or it would be partially accepted. So we have to apply our clipping algorithm to obtain the result. So moving forward to its implementation, the four borders of window actually divides the region into 9 parts. Then we have when we encounter the line, we first assign the region code to those endpoints. So let's discuss how the region codes are given. So we can take a window reference in any 4-bit order. That is, here I have taken the most significant bit for top, then for bottom, then for right, and then for left. According to you, if you would wish to change the order, you can change, but the region codes then would be differ from mine one. So here the region codes are assigned. So the bit position, if a region code in a region code, if any bit is 0, that means that lies inside that particular border. Suppose if we talk about our central region, it is 0000. That means it is below bottom border, below top border, above bottom border, towards the right of left border, and inside the right border. That means it is not lying outside the region, and hence it is completely 0000. And let's talk about this one. If it is, I mean, this is 1000. Here this is 1 because it is outside the top border. As I have already discussed, that we are representing first bit for the top one, and then for bottom, then for right, and then for left, and hence it is 1000. Now let's talk about 1010. In this, the it is, since it is lying above the top border, and also it is lying outside the right border, hence it is 1010. So we can conclude that the bit position of the region code is containing 1 if it's outside of the corresponding window border, and 0 if it's inside that corresponding border. So let's discuss some of few of the lines as an example, so that we can clear our concept more. So let's first discuss about P5 and P6. When we use our algorithm, we first check that the region codes which are assigned to our endpoints, are they 0000 or not. If they are 000, that means that is lying inside our window, this dashed rectangular region. That means it lies inside our window, and hence the line would be completely accepted. And now let's talk about P11 and P12. So we can see that it is not 0000. So hence we will apply our algorithm. So in our algorithm, what we do is we go for bitwise AND operation. That is, if they are not 0000, we go for bitwise AND operation. If the result comes 0000, then we apply a clipping algorithm, else the line would be completely rejected. So here we can see that the endpoints are not 0000, and even after the AND operation, bitwise AND operation, the result doesn't come 0000, since we have 1 at this bit position. Hence the line would be completely rejected. Now the line P13, P14. In this we can see that the both the region codes again are not 0000. Now we will apply bitwise AND operation on them, and we see that the second bit from left is containing 1. Hence its result won't be 0000, and hence it would be completely rejected. Now coming to our next line, P3, P4. In this case, we can see that both the region codes are again not 0000. Hence we will apply a bitwise AND operation. So on applying bitwise AND operation, we will get 0000. Hence we have to calculate bitwise AND operation. When we will apply bitwise AND operation, we will have 0000. So we will apply now our algorithm. According to our algorithm, we can select one of the point which is lying outside. So in this case, both the lines are already lying outside. So we will select one of the parts. Suppose one of the endpoint. So let's select P4. Now using P4, we can see this. We will be calculating point of intersection with one of the border region corresponding to it. That is, if we calculate the point of intersection with one of the borders, we will get this. Then we will update the endpoint, the region code of endpoint P4. When we will update the, we will have 1001. As now it is lying even to the right also, means to the left of the left border, and it is outside, it is not on the window, hence the region code would be updated to 1001. Now we will again apply bitwise and operation. So on applying bitwise and operation, we can see that even the least significant bit of both the endpoints are now 1, hence the result won't be 0000, and the line would be completely rejected. Now moving forward with line P9 and P10. So in this case, we can see there's the endpoint of P9 is 0000, but P10 is not 0000. Its region code is 0100. Hence, we will apply bitwise AND operation. So the result would be 0000. Then we will find the point of intersection corresponding to the border where the P10 is lying outside. So we get this point P10 dash, and we will update the P10 to P10 dash, and we will update its region code to 0000. Now since the both the now points have 0000 as their region codes, then this portion would be completely accepted while this portion would be rejected. Now moving forward to next case, that is P7 P8 for line segment. Here both the line segments are although outside, but their and operations are their bitwise end operation will be 000. We'll apply the same thing which we applied at our last case. In this the point of intersection corresponding to the border is P8 dash. So we will update P8 dash P8 to P8 dash and updates its region code to 0000. Now keeping this as one of the reference, and now selecting the other point line outside. So here the point is 0001. So we again apply bitwise AND operation. We will again get 0000. Then we will again apply our algorithm. And once we apply our algorithm, we will get this point of intersection, which will be P7 dash, and we will update P7 to P7 dash and updates it region code to 0000. Hence now we can see that this portion is would be completely accepted because the region points are the endpoints region code are 0000, and the rest part would be rejected. That is from P8 dash to P8 and P7 dash to P7. So this was all the concept. Now let's talk about how we would be applying it in a code. So we should be knowing our this algorithm. So when we the first step is we will assign the region codes to our endpoints. Then we will first verify whether the region codes are 0000 or not. If they are 00, the line would be completely accepted. Else, we will apply our logical AND operation or say bitwise AND operation for both the region codes. If we find the result 0000, then we will go for clipping. Otherwise, the line would be rejected. Okay. Now, when if the result comes 000, we go for our clipping algorithm. Then what we'll do, we will choose an endpoint of the line that is outside the window. Then find the point of intersection at the window boundary based on our region code. Else, then we will replace the endpoint with the point of intersection and update our region code. We will repeat again the step 2, that verifying whether both the endpoints got to 0000 or not, and if gets, then will be accepted, rejected, and same this process will go on, and till the line is completely accepted, rejected, or we have a result. And this process would be repeated for each and every line. So as earlier I have already discussed that this algorithm has an advantage of reducing the number of points of intersection to be calculated in significant amount. So we actually, as my prior cases, we won't be calculating the point of intersection for these 3 lines. That is, it has reduces a significant amount. Thank you. Now I would like to hand over screen to Nikhil.
Thank you, Himanshu. Thank you for to give me the time. Good morning, one and all. Presented over here, respected director, sir, alumni, and all faculties, and my dear batchmates. Today, I am Nikhil Chauhan, a student of Dr. K.N.MIET Foundation of Engineering and Technology, BTech third year from CS branch. Want to tell you something about the two basic algorithms which are used in the computer graphics. Firstly, I want to tell you something about the Cyrus backline clipping algorithm. The Cyrus backline clipping algorithm is more efficient than Cohen-Sutherland algorithm because it involves similar calculations like dot products, and also involves with the parametric line of equation, so that it makes our calculation simple and easy to do. To elaborate this equation in details, I would tell you something about briefly in the 7 steps which are basically used in this algorithm. Such as in step number 1, we should take a rectangle window block with the two dots P0 and Pi as shown in the figure inclined to it. After that, the parametric equation which we get after evaluating is the Pt is equal to P0 plus T P1 minus P0, where P is the parameter and for T we will discuss later in the next slide. After that, we are going to mark a normal point that is perpendicular to the edge as shown here in this figure. And after that, we are going to take we have to mark the 4 point randomly. One is inside the rectangle, second is at the intersection point, and third is outside the point, and one is at the edge. After this, we are going to mark the distance vector like this. And after making distance vector, we are going to do the dot product with the normal of this distance vector respectively. After doing the dot product, we are going to involve the three cases as it is shown: case number 1, case number 2, case number 3, one by one. Let Ni be the normal edge Ei. Now pick any arbitrary point edge Ei. Then the dot product is Ni dot Pi Pt minus Pei, which determines that the point Pt is inside the clippage, outside the clippage, or on the clippage. To study in detail, I want to tell you something about this. As in case number 1, when theta is greater than 90 degree, when dot theta is greater than 90 degree, the dot product of normal with the parametric line of equation is always less than 0, which implies that the point Pt is always inside the rectangle. In case number 2, when theta is greater than 90, when theta is less than 90 degree, it means that when the dot product of the parametric equation with the normal is always greater than 0, which implies that A is always lie outside the boundary. In case number 3, the dot product is always equal to 0. It means the point is at the intersection of the edge, which implies directly that which part of the polygon we have to clip. As I have told you earlier that I will talk the value of t in the later slides, it's the time to talk about the value of t. To calculate the value of t, while we are going to take the point of the intersection. At intersection means when theta is equal to 90 degree, and when when the dot product of the normal and the parametric equation is equal to 90 degree. At intersection point, I have told you that when the dot product is also equal to 0, as theta is equal to 90 degree, it is equal to 0. We know that the parametric equation is this. After replacing the point Pt with this equation, then we are going to get this. After multiplying and evaluating all such calculations, the value of t becomes t equal to ni dot p dot minus pei minus ni dot d. It means that the time we require for the polygon clipping is depend on this equation. For the value of the equation of the t, it depends on the three conditions. The three conditions which are in front of you, that the ni should be not equal to 0. It means that if it happens, the error can't be happen. Error cannot happen in any case. In case number 2, when d is equal to 0, when d is not equal to 0, which means that pi is not equal to p naught. If it happens, it will make a point, not a line. But we need a line here, not a point. In case number 3, ni dot d is not equal to 0, means p naught pi is not parallel to edge. If it happens, it will outside to or inside the boundary, then there is no question of the clipping. After doing this algorithm, I should further proceed for the polygon clipping, that is the Sutherland-Hodgman algorithm. Another name of the Sutherland-Hodgman algorithm is the polygon clipping. The basic concept which we are using is that we are going to clip the we are going to clip the unnecessary part of the polygon which are going out of the window, that is the left part, the right part, top part and the bottom part. A polygon can also be clipped by specifying the clipping window. Sutherland-Hodgman polygon clipping algorithm is used for polygon clipping. In this algorithm, all the vertex of the polygon are clipped against each edge of the clipping window. Further proceeding in this, we have a major task which we have to follow over here is that clip the polygon so no portion of the polygon remain outside the window. Our task is that we have to clip all the polygons so that our portion of, which are remaining outside of the window should be not be presented over here. As you are seeing in in this image that it is here, it is this, it is an unnecessary part. We have to clip all this part with the help of the algorithm. To proceed with this, the major four steps which take place are the left clip, right clip, top clip, and the bottom clip. Left clip. The question may arise: what is the left clip? It is nothing, just only the left part of the star, left part of the polygon, which appears outside the window. Similarly, we do another steps: the right clip. The right clip is also nothing. It's just only removal right part of the window that appears outside from the right part of the window. Top clip, top clip is same like that. We are going to remove the top part of the window. In the bottom clip, we are going to remove the bottom part of the window. After doing all the clipping, we can say that a polygon has been clipped like this. And the left clip, you are able to see this part. The left clip has been left clip. After doing left clip, the part has been removed. Right clipping, this right part has been removed. Top clipping, the right top part has been removed. And bottom clipping, the bottom part has been removed. By doing all this clipping, the polygon has been clipped totally, as was shown in the figure. After doing all this, the polygon clipping is done on the basis of the four cases. The polygon clipping is done on the basis of the four cases that are the case number one, when the edge is inside to outside the polygon. It means that in the case number one, the edge is going from the inside to outside of the boundary. As you can see in the arrow is looking outside the boundary. It means that the updated edge for V2 is V2 dash, and we are going to reject the line V2 dash and V2. It means the output is also the V2. V2 dash. In case number 2, we are going to take the part when the edge is going outside to inside the boundary. Output for this equation is the V1 dash and V2, because the outside part we have to remove and we are going to take the inside part too. So then we can also see that the output is also only the V1 dash and V2. The rejected part is the V1 and V1 dash. This part we have to reject, so it is the rejected part. In case number 3, when edge is completely inside the window, it means that when edge is already inside the window, it is not necessary to remove the unnecessary part. Unnecessary part is nothing, so we are going to remove nothing in this case. The output is already a V2. In case number 4, when edge is present outside the window output, it means the output is null, and then we reject the V1 and V2 because it present totally outside the window. That's all the Sutherland-Hodgman polygon clipping and Cyrus backline clipping algorithm. Thank you. Now I want to call the Piyush to hand over the slide. Thank you, everyone. Please, Piyush.
Thank you, Nikhil. Text clipping. So in text clipping, what we do that we just edit the portion which is outside the view plane. So basically in this text clipping, we eliminate the portions which is outside the window, and for that we have 2-3 methods which we use according to our requirement. Like we have all or none string clipping, all or none character clipping, and last one is text clipping. So all or none string clipping works on string, whereas all or none character clipping and text clipping works on character. We will understand these by one. So first one is all or none. So first one is all or none string clipping. So here, as you can see, we have two box. These are called as window. So there is a window, and we have string one and string two. So in this method, what we do that like we have a string one and a string two, and string one.
Yes, sir. Maybe.
processing part, we can use the clipping. Okay, so can we say the greedy algorithm used in computer graphics? We can use greeting algorithm used in clipping, for clipping.
Yes, sir.
No, greeting algorithm are part of computer algorithm portion, you know.
Sir, it is a part of data structure grading algorithm.
Yeah.
Yes, sir.
Algorithm subject.
We have studied
Okay,
last time. Yes, sir.
where
In the
yes. Okay, and the next question is, uh, if any point satisfy in the point clipping algorithm, what are the concept behind this?
sir, if sir, like we have sir x-axis and y-axis. So if any point satisfy the condition, like sir, the point must be inside x minimum and between x minimum and x maximum, and
Yes,
y minimum
x
and y
x
maximum. So
minimum
if
x
any point
minimum less than equal to x, and
yes sir,
less
so
than equal to
that
x
point lies
max.
inside that.
Okay,
Have three strings in this string 1, string 2, and string 3. So as you can see in string 1, st, the character st lies outside the window, and r lies at the window, at the boundary of the window, and remaining ing and 1 lies inside the window. In the same way, if you came to string 3, s lies outside the window, t lies at the boundary of the window, and ring3 lies inside the window, and string 2 is completely inside the window. So after clipping, in all our non-factor clipping, what we do that we just eliminate st and r, and we keep ing1 in string 1, and we keep whole string 2 because it is inside the window, and in string 3 we just eliminate st and keep ring3 because it will because it is inside the window. So after that we have our last clipping, which is text clipping. So it is very similar to last one. So here, as you can see, we have three strings in the same way, and R lies at the boundary of string 1, and T lies at the boundary of string 3, and the string is completely inside the window. So after clipping, we just eliminate ST and we keep R, I, N, G, and 1. In last one, we eliminate the portion, we eliminate the character which lies at the boundary, but here we keep the character which lies at the boundary. So we just eliminate st of string 1, and in string 3 we just eliminate s and we keep remaining tring3, and we just keep string 2 completely because it lies inside the window. So now I would like to request sir for further.
okay, thank you, Piyush. Now I request faculty members and alumni whether they want to ask any question to the students. Please, Prabhat sir.
कृष्णकांत जी कहाँ हैं? जरा वीडियो ऑन करिए, वो कुछ क्वेश्चन है उनके, वो पूछना चाह रहे हैं. कृष्णकांत, कैन यू ऑन योर वीडियो प्लीज?
Okay, now I would like to invite Ayushi Prakash ma'am for concluding the today's session.
Hello everyone, a very good morning. A very good
Good morning,
morning to one and all present over here. So first of all, I would like to give my sincere gratitude and thanks to all the participants who have joined this webinar. A very, very thanks to all of you who have given their valuable time here and
Thank
listen
you,
our
ma'am.
speakers. So I would like to give my vote of thanks to, special thanks to Dr. Dipankar Sharma sir, our director, Dr.KNMIET, Dr. Prabhat Srivastava sir, director, KNGD MEC, Dr. Manoj Agrawal sir, director, Dr.KNMEC, all the faculty members, and special thanks to our alumnus of batch 2015, Dipanshu. Hi Dipanshu. Hello.
Yeah, hello, ma'am. Can you hear me?
Yes, Dipanshu, have you heard all the speakers and their learning and their thoughts?
Yeah, I have.
I would
Yeah,
like to invite you if you want to ask questions or if you want to suggest something or if you want to share some information among us.
yeah, sure. First of all, congratulations to whole KNMIET CSC department for arranging such webinars at this critical time of COVID-19. Congratulations to all. And basically, these sessions will definitely be helping everyone. And thanks, Aishu ma'am, for inviting me to this webinar. It's a really honor for me. And regarding this execution, I would say very well explained, Himanshu, Piyush, and Nikhil. You guys, really did a super presentation. And the best thing I feel is the way things were arranged in form of PPT. So very very good thing basically. And regarding this topic, basically I would not go into execution part, but I would say everything whatever we are seeing in front of monitors, everything, it's just a part of computer graphics. It's a frame and everything. So this is basically practical use. And in the IT industry, I would say we hardly use computer graphics, but definitely we used in developing some educational software where screen representation is required and all. So it was a good overall experience. You guys really explained very well. So
Thank you,
that's all,
sir.
ma'am. Yeah, that's all, ma'am, from my end. If you have any questions, you definitely shoot at me.
Thank you, Dipanshu. Thank you so much for being with us, for sharing your feedback and educative and edifying way that you have shared. So we are so grateful and wanted to share gratitude that you have shared your way, that comprehension, our ability, as well as understanding of our students also. Thank you, Dipanshu. I must want to congratulate our speakers, Nikhil, Himanshu, and Piyush Pandey. Very good speakers. You have done good, and
Thank you, ma'am.
best of luck for next seminars and webinars. Thank you, Shubham sir, for nice moderating. You have done good. Thank you, everyone who have participated.
Okay, thank you.